Hello, good morning to all of you. My name is Nitin Bhat, and I welcome all of you to this session on ethics in AI and overcoming product bias. So, if you have questions or feedback about this presentation, please feel free to reach out to me on Twitter. My Twitter handle is Nibat. I'll look out for your questions and feedback. So, with that, let's get into the details. So the agenda for today is quite packed. We are going to cover three big areas. Number one is ethics in AI. Why do ethics really matter? And we'll go through some examples of it. The second piece is around practices in consumer internet. How is this space kind of evolving in the consumer internet space? And the third one, what I want to help and share is how do you actually discover bias in your product, and how can you, using certain level of techniques, uncover your black box machine learning algorithms and understand the decisions which are actually getting made on that. So that's what I'm going to do in today's presentation. So let's come to the first part. Why do ethics matter? And why do ethics in AI matter? Before we get into that, let's try to really understand what are really ethics. And ethics, it's a really, the definition being that these are actually moral principles which govern behavior or activity of individual or group of individuals. That's what ethics really is. And what I strongly believe is ethics in artificial intelligence lead to a lot of very good outcomes. It leads to your AI being predictable. That means it always has a predictable end state. It is auditable, that if need be, you are able to audit why a particular decision was made by your AI if it is transparent and auditable. Another aspect of responsibility is another piece of ethics is being incorruptible and not being subject to manipulation. That's what your AI algorithms should strive for, which is uncorruptibility. And the last one is being responsible. Now, as you go through these definitions, I want to make sure I give you certain examples which will light up this scenario and give you a context of what I'm actually talking about. Let's take example number one. Example number one is, this is a bank. Could be a consumer bank, could be the normal brick and mortar bank. And what the bank is actually doing is it has designed a machine learning algorithm to recommend approvals for mortgage applications. Now, there is a possibility that applications of certain people are getting rejected. And that makes you think, what could be the reason? I can give you certain context on this, that race and gender definitely would not be part of the algorithm. So the algorithm is blind to gender or race level data. But there is a possibility that it is taking into account where people are actually living. What is the zip code? And that particular zip code could be associated with a low income neighborhood. And because of that low income neighborhood, that could be a reason your machine learning algorithm could be rejecting applications of certain people. And that is where, if your AI is ethical, that means based, when you actually uncover your AI algorithm, you can find it's auditable and transparent, and you can come to this deduction that it was rejecting people on a particular zip code based on low income thresholds. So that's where I'm actually connecting the dots. The second scenario is in a ride sharing app. You see their car sharing app, it's actually ride sharing. So there is a way riders and drivers can rate each other on a particular score. Now, there could be a scenario where this could be manipulated. That is, the driver and the rider always give a full rating to each other, 5 out of 5. Then the question comes, how accurate or how authentic is that score? So your AI algorithm, if based on right way, is incorruptible, you want to make sure that it's incorruptible. That's piece one. Piece two is if the rating is purely a whole number, which is that the rating is from 1 to 5, it's not really a fraction. How come when you actually look at your own rider score, that is in decimals? So if your algorithm is, if you are explaining as a product manager, you need to explain what is the sauce behind that particular score. It's not just the scores given by the drivers, it could be some other reasons, and that is the responsibility of the product to explain that why, what are the other factors leading to that particular score in decimal. The third particular scenario, which is kind of food for thought for this area, is flagging abuse on social media platforms. The key area here is that how do you discover such content? That is, first discover the content and then you rate it in a fair and a consistent manner. So that is also an area of significant research, and it's a really hard problem today, that how do you actually classify such data, whether it's regression or classification algorithms, and then how do you actually rank and rate them in a fair and a consistent manner. So that's overall how the ethics in AI piece comes together. Now I want to take you through certain examples where these kind of biases can actually harm society, and we'll go through some mitigation plans of how to overcome them. What I have actually taken this data is from the Future of Privacy Forum, and I will cover through a couple of scenarios which actually will help you understand this problem. The first one actually being loss of opportunity, that if there are not the right safeguards and right guardrails built, it can lead to differential access to insurance and benefits for society or individuals and cause them loss of opportunities. The two specific scenarios under this are, number one, the auto insurance prices are increased for night shift workers, and that could be deemed unfair or illegal. So that is example one. Example number two is higher termination rate for benefit eligibility by religious group. Again, that is also something which is avoidable. Another scenario which comes into mind is the economic loss, that if you don't have the right safeguards and mechanisms built, it could lead to differential access to credits for different people. Again, examples being denying credit to all residents in a specific neighborhood, that would be illegal. And not presenting certain types of credits to members of a certain group, again, could be deemed unfair or illegal. Now, these are scenarios where which can cause societal or collective harms or individual harms because the right level of safeguards and programs and AI algorithms are not built the right way. Now, let's look into what are the mitigation sets. If you take the same example, which I was covering in the previous slide around economic loss and being the differential access to credit, what would be a good framework would be building the right laws and policies, and your program actually is adhering to the right laws and policies, setting a set of business processes which actually flag any kind of anomalous behavior. And more from a data science, machine learning algorithms part, there are two pieces. The piece one is the algorithmic design, that making sure that the algorithm, when it's actually making decisions, is able to trigger reviews, human intervention if it finds anomalies or some level of problems in the detection piece. The second one is the data methods. When you're actually collecting data or doing any cleansing of data or doing some data classification, that your data methods don't actually amplify historic bias. So that is a really strong way for you to look into mitigations to solve these kind of problems. So from an AI ML perspective, always think out the data methods and the algorithmic designs which have been highlighted here. Now, shifting gears a little bit here, what I want to do is I want to take a very controversial set of capabilities and how different vendors are looking at that capability, and give you a flavor of how this is existing in today's environment for products and capabilities. The capability which I'm going to talk about is going to be computer vision or face detection capabilities. I was working on a startup before on this particular area, and this is based on my inference of different level of vendors and capabilities when they actually do computer vision. So what I have actually done in this particular example, what I have done is taken my picture and ran it through certain level of facial detection attributes. And what I want to highlight here is that there are some questions as I was thinking through I talked to you about in the first slide about ethics in AI, that are these really the right capabilities you want to expose, and how are you actually if you are giving capabilities like this out, what is the reason or what is the secret sauce behind this, or at least explain to the customers that how are you actually getting to this deduction. So in this particular one, if you look at this picture, the tags what is able to 100% identify really well and with a really good level of confidence is that, hey, this is a human face with a 98.6% probability. That's a great accuracy rate. It is able to classify that, hey, this is able to gender, this is able to identify my gender as a man, and it's able to find some level of smile association at 77%. Let's look at other attributes which are interesting from this analysis. It's able to based on certain how to flag content on internet, which could be, I was talking about, which could be for adult consumption, or which is racy or is not right. So there is some level of scores which these vendors actually give to you around associated with the picture. Now it's saying, hey, the adult score is really low on this, or same for the racy score. But it's also able to correctly identify the people portrait associated with it. It gives me a really high score of almost 93%. Now this is the area where I was thinking about this particular bit is the age. Yes, it's able to accurately identify my age, that I'm in my 30s and I'm a male. But that's really the question, that uh, there is a possibility this age could be misused. If I was giving an interview over a video conference, and the company which is taking my interview is using this software. Based on the age, could there be something which may lead to some other outcomes we need to think through? I think that's where the ethical piece of your software, of your products, come into play. Let's look at other example, another vendor. So the vendor here is able to give me a sense of, based on the picture, a certain emotion or certain certain other attributes which it's able to find based on my picture. It could be attributes associated with joy, sorrow, anger, surprise, exposure, blurred, or headwear. Now again, the question which is thought provoking is that, is something like a headgear detection be a factor in employment if the picture is part of a resume or a video employment which determines employment? I think those are the kind of factors you need to think through, that under what cases would exposing the capability of headwear detection be right versus wrong. So I think those are questions or things you need to think through as you are actually developing and building your products. And this area of AI, ethics in AI, I really hope I'm able to give you a teaser today. But in a lot of universities, this is actually a thesis or a line of computer science itself. A lot of what I have known is there are more than 5 or 10 universities offering programs like PhDs or elective subjects for their masters in computer science or Department of Philosophy under the space of ethics for AI. Now, as you have learned about this particular area, I want to share one really good way how you can actually unbox your machine learning algorithm and get into the details of how decisions are actually made. So if you look at the slide right now, there is the black box that based on certain factors of age, gender, BMI, it makes a certain decision on outcome, and you have no visibility into how that black box is actually being able to make that decision. But if you're able to break the machine learning algorithm and you're able to understand the factors, how much of each one of these factors determines the overall outcome, that's a really, really good way to understand how decisions are actually getting made. So one of the first challenges is that models on their own are really accurate and powerful, but they are still black box. That's one of the biggest reasons you would want to unbox this black box. And what I also seen in my experience is, if you know the inner workings of these models, like random forest or XGBoost, that really help you with the transparency, compliance, fairness, and trust of these algorithms. So what I would really suggest as part of learning is, I have shared certain examples. In this particular example, what I'm going to cover is the census data, which is available available at this link. And what you can do is, based on the census data which is available, the machine learning program is going to predict whether the person is going to make $50,000 in a year or not. So that is really the data set. And what I have actually used is the SHAP framework to actually unbox the black box machine learning algorithm. And I've used a really good cool interpreter, which is actually shared here in this particular example. Now, when I actually ran the interpreter and the ML interpreter on this particular, I'll not get through those level of details in this short presentation, but the idea really is that based on that, I can actually decide to get on a particular segment and look at data from that one particular segment. In this slide, what you can actually see is the slide number one, the picture number one. What you see on the top is based on number in the census data. It is also a factor of how many years of education does that person have, and based on that particular filter, you can actually see the output. Remember, when you look at the black box, there is no such segmentation or no such you can go in on one particular factor. But using the machine learning interpreter, you can actually zone in on one particular factor and go into this. And also for this particular exercise, what I have actually limited is, I have limited it to 1,000 users, because the browser kind of supports 1,000 users. And what this graph actually shows you is a density scatter plot for each of these features. You can get into years of education, number of hours a person actually works, whether they are married or not. So all those things in the census data, if you do that exercise, you will be able to pivot on each one of these classifications and look at data from that perspective. So very quickly, what you can see here is, if you see the education in number of years, as it goes towards the 10, 12, 14 time frame, that number of years of education, it kind of goes up. That means your data kind of grows as the number of years of education go up. But after a certain threshold, it actually climbs down. So that is an interpretation of your data using ML. So that is one segmentation. The second one is the hours per week. Now, hours per week on an average in the US is 40 hours. But if you look at this segment as well, it goes from 10 to 20 to 40 to almost 90. And it builds you a really good graph and a visualization of how your data looks based on a particular segment. Now, again, this as product managers or budding product managers or data scientists, people who are on the call today, I would highly encourage you to get equipped with these kind of things, like understanding how ML tools work, what are the levels of, even if you don't understand the core technology behind it, but understanding how decisions are getting made, how data is interpreted, what are the kind of tools which are available for you to see segmentation, super, super powerful for a product manager. So at the last, I would like to leave you with really interesting some resourcing for your reference. The first one is a really good paper around how to document data sets. I found this paper to be extremely good. The how to define the characteristics of data, test results, recommended uses, motivation of data. Highly recommend for you to read this paper. The second one was the AI ethics resource kit, a tremendous amount of great research done by the Fast AI team and one of their founders. So I would highly encourage you to look through those frameworks and try to build those kind of capabilities in your product. The third one, which is a really interesting one for product managers, is also familiarity with law and compliance. So if you're a product manager, I'm not saying for you to become lawyers tomorrow, but it's extremely important that you understand laws governing personal identifiable information, which is PII, GDPR, PIPEDA, which is the law in Canada, which defines accountability, consent, safeguarding data, and compliance. These are essential in today's times for product managers. And the last one is the interpret.ml. Highly encourage you to try it out so that you can actually unbox your ML and understand what are the kind of factors which are actually helping you determine the result set which your ML actually brings. With this, it's a wrap on today's presentation. I hope you enjoyed it, and looking forward to meeting you in next version of this talks on product school. Thank you.